coming back to the matter of the machine learning part, uh, I'm not saying all, but majority of the researcher also they are looking for sector. So that if I'm a nutritionist, I'm looking for the nutritionist. If I'm a geneticist, I'm looking from the genetic perspective. If I am, say, epigenetic, so that I'm looking from that perspective. But the good thing with the machine learning and the technologies, we can combine data coming from all sources and accomplish the objective that we are looking for.
Welcome to the Feed Science Podcast Show. On behalf of Wisenetics, my name is Adam Farrenholz. I'm coming to you from North Carolina State University's Animal Food Manufacturing program. My guest today is Dr. Ghader Manafiazar. Dr. Manafiazar is an assistant professor at Dalhousie University in Nova Scotia, working in the area of ruminant feeding and nutrition. Ghader, how are you today?
Thank you so much, Adam. It's a pleasure to be here and talking to you.
Yeah, we're very, very glad to have you. If you wouldn't mind, could you introduce yourself to the audience and give us your background and how you came to be doing what it is you're doing there at the university today?
Yeah, this is Ghader, as you mentioned, assistant professor at Dalhousie University, Nova Scotia, Canada.
Mhm.
And I work here for the last 5 years. But before coming here, I worked for a couple of years at University of Alberta in the west part of the Canada, where I trained on the concept of the feed efficiency in dairy cattle. Then later on, we were thinking about connection between the feed efficiency matter and what animal eat with their carbon footprint, and namely focused more on the methane emission. So then taking roots from different perspective and looking for this concept from different perspective, including kind of the having a feed additives to mitigate their carbon footprint, or looking for their genetic potential on the methane emission, and lately implementing some advanced methods like the machine learning to see that how we can come up with some solution for these matter of the greenhouse gas emission and improving feed efficiency.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
Excellent. So, as you mentioned, a lot of your work is related to the types of things that we might feed and or the feeding strategies that would go into reducing that carbon footprint. And we know that that's something that kind of no matter what someone's opinion might be about, the true impacts or what the science says or any of that, one thing we do know for sure is that governments and consumers are very interested in seeing us pursue this pathway. So regardless of any of the rest of it, it is something that everyone has an interest in and should have an interest in. What are some of I'd like to talk about strategies that involve both things like the feed additive side and the potential things that we can put into the feed that are meant to perhaps do something like reduce methane, but also things related to like the feeding strategies, the ingredients that we already use. So if we could, I'm interested in potentially starting there. Are there things that can be done just on the basic formulation, nutrition, ingredient choice things that we do that could help with that before we even get into additives and those types of things that we might have to pay to put into the feed?
Yeah, Adam, before going on the strategy matter, I would like to give some facts about
Sure. Yeah, absolutely. Please do.
the carbon footprint of the industry. So then, as a scientist, yes, I also acknowledge that there's a contribution coming from the agriculture sector and mainly from the ruminant animals to the matter of the global warming and methane production. But we need to know that their contribution is about the 13%, 13%. Total, it's this number is a little bit different from the
Sure.
concept of a different country or the management system, but it's on average. And from that 30%, So then it's something about the 60% comes from the ruminant animals. So then giving these figure, it's kind of the significant concept, but we need to know that since 1815, the amount of the contribution, the quantity of the contribution, it's almost the same over the
Hmm.
years for the agriculture sector, meaning that back in 1850s, we didn't have any more sources for carbon footprint. So then agriculture and forestry was responsible for 100% of the greenhouse gases. But now it's at 13%. So then the quantity, it didn't increase, although we increased the production in the matter of the milk production, meat production, but our contribution stayed almost the same. And in the last couple of years, we see decrease in this quantity amount still, meaning that with the improvement of the efficiency and mainly feed efficiency, we can take really great steps toward mitigating the carbon footprint of the industry. And as a matter of the strategy, so that mainly it's categorized in two concepts: long-term strategy and the short-term strategy. Long-term strategy is mainly about the genetic selection of the animals. In other words, we're making the foundation for the next generation. And we can see this progress year over year. But it's a long-term solution. It takes
Hmm.
a while to get there. But at the same time, there are some sort of the short-term strategy. That short-term strategy could could include adding feed additives. And the other point is, as you pointed, and there are some other management practices that we can take toward the mitigation. So that meaning that we have some sort of the ingredients. It's a matter of the what ingredients we put for the in the total mixed ration for the animal, for the ruminant animal, then we can have a different carbon footprint. For example, if we talk about, say, the different, the main thing for the methane production is about the percentage of the forage to concentrated. So that
Hmm.
when it's a different, more forage means that more methane produced because animal requires more time and different microbial population to digest those materials. But but the different percentage, say, there are not that much differences in the animal performance if we go from 55% forage to 45% concentrated, if we make it 60% forage to 40% concentrated. So that 5%, but it's a significantly affect the amount of the methane the animal that produces. And there are many research in this matter to find out what would be the optimum amount of the, as an example, forage to concentrate ratio in order to mitigate the carbon footprint at the same time don't affect the amount of production that animal they're having. Other point would be at this moment, I do have a couple more projects that we can talk on the detail of.
Sure.
On the one of which is we are trying to uh, have some sort of the tool to measure carbon footprint from herd, because majority of the research at this time we are focused on the individual animal carbon footprint. But the question is, how about my herd? So then, is there any management practices are associated with the methane emission, carbon dioxide emission, or nitrous oxide emission? So then we are trying to find out what are the management practices that are linked to these particular gases. Then at that time we can come up with some sort of the conclusion or recommendation for producer. For example, if we clean uh, if we clean the barn twice in a day, are we going to have a different contribution toward the carbon emission?
Hmm.
Or if we feed animal 3 times in a day compared to the 2 times in a day? Or if we have pusher instead of the bobcat to push the feed toward the animal? There are the things that we are trying to find out. And the point is, we are trying to see that if, as you mentioned, there are different management practices that doesn't require so much change, still we can improve feed efficiency at the same time decrease the amount of the carbon footprint for the industry. Hopefully I answered your question. If there are anything missing, just let me know.
Oh, sure. No, no. And I think we're just going to keep going down some of those roads. I think there's I made a few notes here as you were going. Before we get back to what we're actually potentially feeding the animals and talk a little bit about the feed efficiency, one of the things I always find interesting when I'm having conversations with other academics, and hopefully the audience does as well, is actually learning how you do what you just talked about. I imagine determining the amount of methane produced by the animal is a complicated thing to do when you're doing the individual ones. And then I imagine from the standpoint, I imagine also this is where some of your machine learning, artificial intelligence things come in, these large data sets. When you're talking about trying to look at management practices and carbon footprint on more of a global perspective, that's also particularly complicated. So, can you give us just in brief some ideas of how you actually go about doing that kind of research that you're doing?
Yeah, this kind of the research comes from my conversation with producers.
Hmm.
So then like that we have a wider perspective in this matter. Some people they don't believe it. Some people they take seriously, and some people they take seriously and they take action toward that one. And during my conversation with the producer, I was saying that so then everybody has this concept of the sustainability in some way or other around. I was talking to I was touring with a group, international group, a farm, and at the time that one of those people coming from Europe, they asked a question that what are the steps that the Canadian dairy producer they are taking toward the carbon emission and mitigation, and she said that we are doing our best.
Hmm.
And I was among the audience. I said that that's not the correct answer, although that's a correct, but precisely you need to say that carbon footprint of the dairy industry in North America is among the lowest in the world. So that this is by selecting for genetics and understanding this concept and implementing the technology. Because we know that in my school, in my class, I'm teaching ecology of milk production. I'm saying for the students like every action that we are taking it's associated with the carbon footprint. As example, at this moment I'm talking, I'm moving my hand, it requires energy. This energy comes from some sort of the eating, and that eatings comes from some sources that associate with the carbon footprint. So then meaning that we cannot ignore the matter of the carbon footprint of our practices, but it's a matter of the managing that particular point.
Hmm.
So then back to your question, every producer they are implementing technology or they are doing some sort of the any practices they are working toward this matter of this sustainability concept, but they need to understand the quantification of these action that they are taking. For example, if I'm talking to my nutritionist and we are agreed that this is the diet that I can have it, say with the 16% of the crude protein,
Hmm.
but at this time I could ask my nutritionist, how about if I go down to 14%? And at that time, we know that if it doesn't affect the production of the animal, for sure, it's going to affect the carbon footprint of those animals. So then overall, this is the concept that with my daily conversation with the producer and understanding the concern, I come up with some sort of the ideas to generate these research idea and see that what are the needs for industry.
Sure. So once you've come up with that research idea, what are some of the methods you actually utilize to collect all that data that you need?
Yeah, I look for mainly I have a system view. So then at that time, I try to collect as many sample as I could, but I know that I don't have that much money to perform all of those analysis at the same time.
For sure.
But I'm optimistic. Then later on, I go after fund and say, okay, we did this one, and this is the fund that we are looking for to collect this data. For example, at this moment, I have a PhD student who is working on feeding kelp, kind of the seaweeds that we have in the region, for to see what would be the effect on the methane mitigation. But at the same time, there's a question here. Am I just going to reduce the methane? How about the reproductive performance? How about the production performance?
Mhm.
And after that, we go after those reproductive performance and production performance. Then the next question that I'm asking is how this is going to affect the gene expression of their fetus, the young animal that they have. So then at this moment, I don't have money, but I collected data for that particular. Then
Mhm.
later on, I go after gene expression because we know that kelp is rich in minerals and vitamins, then potentially could affect the development of fetus. So that at that time, although it's not direct genetic manipulation, we call it epigenetics.
Mhm.
effect of the environment on the gene expression, then the question is it going to affect their young one performance later in their life or not? So then I'm following up on this matter. Then the next question I'm asking is, what is the mechanism? So then I'm collecting rumen sample, then sending to the lab. Then at the end of the day, there's a bunch of data coming from different sources. So then combining all of these sources to better understand and potentially come up with early, I'm not calling the detection, but early indicator that we can say, okay, this animal has a potential to have a better feed efficiency and lower carbon footprint.
Got it. Once again, my guest today is Ghader Manafiazar. He is an assistant professor at Dalhousie University, Nova Scotia, in Canada, as he said, as I just basically tried to make Nova Scotia a country. Um, let's since we know we've got some folks that are listening from the feed side, and before we and I think we'll try to kind of tie all the data stuff in together. Let's go back a little bit and talk about the feed additive side. We've heard a lot about the different potential additives that might be able to be put into cattle feed. There have been a few that have been already put on the market that are there to reduce the greenhouse gas emissions. Can you talk a little bit about what the research has looked like as far as looking into and evaluating things like that, how the regulatory environment comes into play as far as they're being able to be used, and what the potentials are. We obviously from the feed manufacturing side of things, we were always interested in ingredients that have a purpose, but also another ingredient to have to just get into the feed can also be a burden. So there's always a lot of interest in, is this something really valuable, and if so, how can we use it?
Yeah. The first point, Adam, when I'm talking about the Canada, I'm not trying to say that it's different than USA.
Oh, no, no, no.
Yeah, so that,
I was just making the point that I stopped with no, it's in Nova Scotia, and I should have mentioned that Nova Scotia is in Canada for those few that are like, "Where's Nova Scotia at?" So,
yeah. And the point is because, like the North American dairy and the beef industry, they're mostly similar to each other. There's not much that differences. But there are some products that are locally available. So that this is particularly related to the matter of the additives that we are talking about. So then there are mainly two categories of the additives. There are some sort of the chemical based one, which I didn't go deeply, but I have read that it looks like there's one get approved in USA recently. So
mhm.
then your listener can dig more because I didn't read that much deeply, so that I don't want to give maybe the false information. But I know that there's one approved, so then they can add to the feed, and that one reduce the methane. But the other points that other category is about the natural resource, for example, seaweeds. So then I know that seaweeds, like they have a different variety, and red seaweeds. I have read that it reduced methane up to 80%.
Hmm. Wow.
That's really amazing. And but the question is, how about the supply? Can we have enough supply of that one to feed the industry? But the other thing that we do have here is kind of the brown seaweeds. It's a kelp one, so then we have a forest and ocean, and sometime during the hurricane season, which is bad some people,
Mhm.
the majority of the people, but it's a good opportunity for others to harvest those kelps that storm tossing out, so then they can collect them and they sun dry it, and they are used for animal feeding in the many years in Atlantic region. So then a colleague of mine, Dr. Ferdin, has showed in lab there's a potential of the 30% reduction of methane by feeding these particular seaweeds. So then, but I follow up this study in using live animal. At this moment, we do have like the 16 dairy cows. So then we feed them with the 0%, 0.5%, 1%, and 2% to see that what would be the effect of these additive in animal diet. When I'm talking about the 2%, just giving roughly an idea, meaning that daily about 400 gram per animal per dairy
Okay.
cow. Yeah,
Wow. Okay.
yeah.
So,
So then we saw that preliminary results. We saw that it reduced about like the 13-14% methane. But the other point is with that. chemical feed additives. I'm not sure about the effect on the other part of the production or the production. But with the kelp, we have seen great improvement in animal performance, animal reproductive performance, and also animal health and immune system improvement. That's a kind of the considered bonus besides methane reduction for using these kelp. So then, and although we have locally available, but I see there's a great commercial opportunity for people that they may get involved with harvesting more kelp and sun drying it and having a market for that particular product.
Sure. And I think that one of the things that you started off with at the very beginning is of that particular part of the conversation is always so relevant, especially when it is a naturally occurring product, something that we can't manufacture. It is that question of supply. And we've talked about it with different products. People would like to explore putting hemp into animal food. And you mentioned kelp, and we've got, co-products, and it's very interesting to do a lot of that work and then determine, hey, this will work very well, but the supply is only found in this one place,
Mm.
and or there's only so much of it, so how can it work? And I would imagine that, again, some of your work then would go into trying to look at the data to figure out how widely that could be spread. And so before we finish up here talking about the actual the work, I'm interested. I know you've started looking into these things related to artificial intelligence, machine learning. I'd love to hear what your definition is of that, because there seem to be all kinds of definitions of what those two terms mean. And then how you see that it can be applied in these production, agricultural research kinds of things, where we've got to consider things related to the animal and things related to the harvest of this material and things related to the availability of this material. And all of a sudden, the data set is so massive that we don't know what to do with it. And these are the technologies that can actually help us make some sense of it in a much neater package, so to speak.
Yeah, before getting in my concept from the artificial intelligence, I would like to get back to the matter of the system.
Hmm.
So then, like when we're talking about the system, uh, it comes from the different sectors, and each sectors we are considering our own kind of the mandate or objective in that particular sector. For example, if a dairy producer, we may say, okay, I would like to reduce my methane, but the point is I'm using feed additives and reducing that one. But interestingly, I had a conversation with a colleague of mine who is doing work on dung beetles.
Hmm.
So then I was thinking that the question is, these adding feed additives going to change the rumen function, and this rumen function is going to be make an effect on their dung. So then, how does it going to affect? Is it going to be increase the digestibility, or there will be
Hmm.
some sort of the nutrient
Sure.
change? Then I talked to
Yeah.
my colleague, and he said that we can test that. And interestingly, when animal they improve their feed efficiency, so that there's a different nutrient composition in their feces, so that at that time the beetles that they're taking that feces, they have a different carbon footprint.
Yeah.
So then the carbon footprint from those particular beetles increased when they are getting dung from efficient animal. That was really interesting, meaning that we are decreasing from the animal side, but increasing from the beetle side. So then
Sure.
that's why I would like to see the system approach, not
Yep.
each sector.
Yep.
So
That
then
makes good sense.
coming back to the matter of the machine learning part, uh, I'm not saying all, but majority of the researcher also they are looking for sector. So that if I'm a nutritionist, I'm looking for the nutritionist. If I'm a geneticist, I'm looking from the genetic perspective. If I am, say, epigenetic, so that I'm looking from that perspective. But the good thing with the machine learning and the technologies, we can combine data coming from all sources and accomplish the objective that we are looking for. As in a particular example, recently we did one work in the matter of the genetics, and we had 50,000 what we call markers or single nucleotide polymorphism to try to see that can we predict low and high efficient cows at from their genomic profile.
Hmm.
So then meaning that the implication is if at the early time of their life, after they're born, if we take their blood sample, we can say, okay, this animal is going to be feed efficient or not. So then, and we did this one with the 50,000 markers. Then with the machine learning approach, we found that we need just only 500 of those markers out of 50,000, which is going to be reduce a lot of money for the matter of the industry and genotyping. So that this is one implication, but in overall, machine learning from my perspective is using information from different sources and testing different objective that we have. But we need to consider these artificial intelligence and machine learning, they are not silver bullet. They're not going to be a only solution for everything. We need to understand the concept and the objective that we have. I had some conversation with industry partner. They said, okay, I do have these data, and I was wondering how you can use machine learning. I said, like it's the first thing is what are the objectives that you would like to accomplish, and maybe simple approach could be more efficient than combining all of those data sources, so that it's a really important. But the other point is beside these project, I'm using machine learning and artificial intelligence for other purpose, which is mainly about providing industry with tools to measure different traits. One example that I can give, it's a little bit off from your audience, like that.
That's
But the
good.
point is, for example, we see that there are a couple animals that they have a sudden death in the feedlot operation, and we see that they have a deformity of their heart, so then their heart become deformity. But the point is, we see that there is a genetic basis for these particular traits. So then some of animal they could be resistant to this deformity. But the point is how we can measure their heart shape, then later on select their parents for this particular purpose.
Hmm.
With the machine learning, so then we are trying to develop a tool so then we can take picture of the heart of the animal and give a measurement, then we can trace back and use their parents that they have more, I'm not calling the resistance, but more potential to have a better heart shape and prevent their sudden death in feedlot operation. So then, meaning that in overall, this matter of the machine learning and artificial intelligence has lots of application, but the main point is what are the objective that we want to accomplish using these technique.
I really enjoyed our conversation, and we've jumped around a little bit, but I think to tie it all back in here at the end before we finish up with just a few questions, one of the things that was really interesting that you pointed out at the beginning was this idea that animal agriculture, and in this case, we're talking about, beef dairy, has produced roughly the same amount of an impact on the planet from when we started doing it, or at least we're recording data of starting to do it, up until now, even though we can obviously produce so much more food now than we did before. And that's all because, as you mentioned, efficiency. And all that efficiency comes from science. And so I think you touch on a lot of things, different ingredients that we might be trying, different methods of doing the research, system approaches, all of these things that we hear, well, and maybe in order to reduce some of the impact we're having, what we really need to do is go back to the old ways. But in reality, it was science that got us here and kept us as efficient as we have been, and it's going to be science that's going to keep us being efficient as we have to feed more people. Going backwards is not going to work. We are going to have to use these tools to make things ever more efficient in order to make this a sustainable thing, not just from the standpoint of sustaining the planet, but sustaining from the standpoint of people being able to afford to eat and find enough food to eat. And all of this science is a part of that.
As you mentioned, I would like to make it clear and conclude by this way that there are two great articles, and I'm reading their title. One of which is the environmental impact of beef production in the United States 1977 compared with 2007. And the other one is the environment impact of dairy production 1944 compared with 2007. These two great articles, they are discussing what we have achieved in the industry using science. And the conclusion is we require for the same amount of the beef at this moment compared to 1944, we require 70% lower animal, 81% lower feed, and 88% of lower water, and 60% of lower land. So that meaning that
Yeah.
we achieve all of this. Mainly, we say two actions, one of which is improving genetic potential of the animal, and the other point, environment that we are providing. So that meaning that that environment could be our nutrition management, our barn management, our watering system, and many other factors. So that meaning that this improvement comes along with the science, and the science shows this great potential. And still, we need to do more because, as you mentioned, in the next 25 years, we are going to have uh, 10 billion people in our planet, whereas just we have so far, just we have one planet of Earth. So then to feed
Yeah.
this population. So
Yeah.
that meaning that we need to increase efficiency per cow.
And the fact of the matter is, I think probably through all of those generations, w- probably everybody in their generation thought, okay, well, this is going to be as efficient as we can be. Well, I mean, we're not going to do better than that. And then something got better. And so even in the last 20 years, I mean, we've done most of the science. It's not going to get more efficient. And lo and behold, it's gotten more efficient. We've found new ways to do things. And so that will continue to be the case. Again, my guest today is Ghader Manafiazar. He is an assistant professor at Dalhousie University, Nova Scotia, Canada. And as we wrap up here, and you actually just touched on one of my first follow up questions is, or here at the end, is good resources for people who want to learn more about that. So those two articles you just mentioned, I would encourage everybody rewind and write those down because those would be excellent things to go read and get a scientific basis for what's actually happened. Are there any other particular things from your particular area of expertise that if people want to learn more, you would suggest that they go look at instead of just relying on what gets reported or what they might see in social media, that things that maybe not aren't as dependable as we would like them to be? What are some good dependable sources for information on this topic?
Yeah, I would suggest Journal of Dairy Science. So then we do have some sort of the lay summary. So then that's a good point. And at the same time, we are sure that they are peer reviewed and more kind of the science based material that we are reading. Because like nowadays, I'm saying for my students, it's really important to decide that what to not read
Yeah.
because there are many things out there and everybody's giving idea, but how likely is back up by science? So that's the one resources that I would say. And in Canada we do have BCRC website, so that it's a beef based one, and it's a really good resources, and majority of those concepts are similar across Canada and USA. It doesn't matter. Yeah, these are the two resources that I would encourage anyone interested. And for sure, in case if anyone has a particular question, I would be more than happy to answer through the email or any connection that they may have it.
Excellent. And you just mentioned something I don't know that anyone's ever mentioned on the podcast before, that many of these journals, scientific journals, that are all now open access because there's no need anymore to have a subscription and have it shown up as a hard copy on your office desk. So they become open access, which makes them more accessible to the public. Also, in many cases, include these lay summaries that are written by the editors. So if you're somebody or somebody who, boy, I'd really like them to do this, but they're not going to sit down and read a scientific article. Oh no, there are these lay summaries that are specifically written for people that don't want to dive into the full in-depth scientific article, don't care about the materials and methods and the statistical design, but
Mhm.
want to know what happened. That's a really, really good point that I don't think anyone's ever made before. Second question then is then just in more of a general sort of a concept, as you've gone through your career and in this case, worked through academia and done other things, what maybe are a resource or two that you found really beneficial from like a professional development standpoint, a particular book or something like that that just really stuck out as to you as a way to help you develop your professional attitude, so to speak.
I consider myself a little bit wider skill set, so that
Hmm.
coming from nutrition, genetics, and lately artificial intelligence. But what I see is in the coming years, I see more room for data scientists
Hmm.
and machine learners. So then I encourage if any of those people that they would like to go through the academia journey. So then I would like to mention that I recommend them to go through many of those data science related courses and machine learning, because if you have that particular skills, then for sure there's a more opportunity for you. And even at this moment, I'm encouraging my students, they are doing some sort of genetics work to find out genes involved in these efficiency or parasite resistance. I'm encouraging them to go through this route to find out better skills in the machine learning. And there are many courses through the course era or any other sources that they can find easily. So that it's a matter of the starting from the basic point, then later on building up on that one. So that's my recommendation.
I think it's a great point, and I think it's what we're going to finish up here on, and that idea of, and it doesn't matter whether you're in school or whether you're in somewhere in your professional career, there's your area of expertise, but then there's all the things that tie into it. So it's going and getting an MBA, or, well, I'm not a statistics, I'm not wanting to be a statistician. Well, that doesn't mean you shouldn't go take a statistics course. I might not be interested in being a data analyst, but I should go learn about how the data science works. And so I think that's true for everybody, is look at the things that support whatever your area of expertise is and try to learn more about them, because that's going to give you those better conversations with the experts in that area when you try to use it and leverage it for your own needs.
Yeah, I supplement in this way that we all know how to write,
Right.
but not necessarily we are not writers. So then
Right.
the same case, we need to understand the stats and these data word, but it doesn't mean that we need to be data scientists or data analysts. But it's something that we need to know, and I'm confident to say that they looks a little bit overwhelming and scary, but they're not. So then
Right.
at the beginning they looks, oh, what's going on with these data concept, but they're not. So then we need to understand those basic concepts and later on to make informed decision about the numbers that people they are trying to sell for us.
Absolutely. Goddard, thank you very much. I really appreciate our conversation today.
Yeah, thank you so much, Adam, for the opportunity.
Once again, on behalf of Wisenetics, I'm Adam Fahrenholz from North Carolina State University. Thanks for listening, and we'll talk to you next time. This has been the Feed Science Podcast Show.